Our final example is probably our most convoluted. That is, given 3 students, what are the chances at least one of them does not return? The key here is to see this at least. And as soon as I see at least, this means there's a ton of options. If I want at least one of them to not return, that could mean 1 doesn't. It could mean 2 do not. It could even mean 3 of them do not. This is a bunch of different options to find, so a lot of times when I see this at least, I want to think about the complement. So 1 of them doesn't return, 2 of them do not return, 3 of them do not return. Instead of looking at this, let's go ahead and think about, well, what is the opposite of this? That is, I've got these 3 options. What is not included there? Well, 1 does not, 2 does not, 3 do not. That means the only thing I'm not including is the chances 0 do not. Well, if 0 of my students do not return, that's the same as saying all 3 return. What's nice about this is a relatively easy probability to find. That is the probability the first returns, and the second returns, and the third returns. It's just that one branch on here, and so first returns, second returns, third returns. It's 0.86 times 0.86 times 0.86, or I can just be super lazy and write it as 0.86 to the third power. Once I get this probability, I need to realize it's not what I actually want. That is, what I'm actually looking at here is a probability at least 1 does not return. And if I want the probability at least one of them does not return, well, I know the probability that all of them return, so I'll just take 1 minus the probability all return. And I'm doing this once again because these are mutually exclusive. Well, if at least one of them's gone, that's the opposite of saying all of them came back. So all I'm doing is taking 1 minus that probability, which will then give me the probability I actually want.